Hello, welcome to Previous the Tutor. In this video, we look at Introduction to Radioactivity Physics. So, we'll be looking at radioactivity, and under this, radioactivity. So, let me just write radioactivity. Now, radioactivity is a branch of physics that deals with the nuclear decay of isotopes which are unstable. Now, radioactivity, this is the spontaneous decay of an unstable nuclei of atoms. All right, let's say the carbon atom is not stable, like its nucleus is not stable. It will decay. All right, it will decay to another atom. Maybe let's say radon. To decay to another atom by either alpha decay, beta decay, or the gamma decay. So whenever the atom is unstable in its nucleus, what happens? It has to decay to an atom which is stable. Now, in the process, it's either it can absorb energy or it can give out energy. Now, this is spontaneous because it happens randomly. You understand? The other, if you can't put it spontaneous, you can say a random. You cannot. It just happens. All right, like that. Now, there are different forms of nucleus known as a nuclei. So this is just a different form. Of a nucleus. Now this will lead to what we call isotopes. If you have heard of the word of isotopes. Isotopes, these are elements or atoms. You can call them elements or atoms having the same atomic number but different mass number. That's a basic definition of an isotope. So these are atoms of the same atomic number but different mass number. What do we mean? Let's say we have three different types of carbon. We have carbon 12, but the mass number is 12. We also have carbon 13, but the atomic number is 6. Carbon 14, the atomic number is 6. So you can say that the atomic number is the same, but the mass numbers, they are different. Now all these are what we call isotopes of one carbon atom. Okay? So all these, they make up one carbon atom. Now these are what we call isotopes. Now going back to our radioactivity, like I started, whenever an atom undergoes radioactivity, it can emit either these three types of radioactive radiations. One is the alpha radiation. The second one is the beta radiation. The third one is the gamma radiation. An element can even undergo all these types of radiations because all these are naturally occurring, and hence it's called natural radioactivity. Let's look at the characteristics of these radiations or particles. Now, when you look at these radiations, these are characteristics of the three types of radiations. I have the alpha particle here, I have the beta particle, and I have got the gamma particle. You must be able to know that the alpha particle has got this symbol, or the beta particle has got this symbol, or the gamma has got this symbol, like Y, but it's not like really Y. Now we have the nature and charge. Here we start from nature and charge. An alpha particle, they're saying it has got 2 protons and 2 neutrons. It's known as a helium nucleus. That's the nickname of an alpha particle. It's a helium nucleus, and it's positively charged with 2 protons, as you can see. So in short, we are saying an alpha particle is positively charged, and it's a helium atom. The nature is it's a helium atom. The charge is positive. For a beta particle, the nature is that it's an electron. The charge is negative. So in case you want to be specific, it's just -1. Why are we saying it's -1? Let's first start with an alpha. Alpha has got this symbol 2. That's the alpha. That's a helium atom. While the beta has a -1, and why there it has got 0. So we're talking about the charge of an electron there. While the nature of gamma ray is an electromagnetic wave, and the charge is 0. So it got 0 and 0. Everything is 0. Now, approximate mass. The mass of an alpha particle is 4, as you have seen there, while the mass of an electron has been given to be 1 over 1,800, while the mass of the gamma is actually 0. Ionizing effect. How strong is it, or how weak is it, or is it moderate? Now we are saying the ionizing effect of an alpha particle is very strong. All right, it ionizes very, very fast. Hence, it can be absorbed by a sheet of paper. A beta particle has got the ionizing effect, which is weak. We know that ionization, it has to do with how that particle reacts with air. When it emits air, how does it react? So you discover that an alpha particle reacts very fast. That's what we're talking about ionizing effect. Or gamma ray has got the weakest ionizing effect. Range in air is very short for an alpha particle. For a beta particle, is short. While for an electromagnetic wave, which is a gamma ray, is very long because that's a wave. Well, what's the penetrating power? How good is the penetrating power of an alpha particle? For an alpha particle, it's very weak. Why is it very weak? Because it has got a very strong ionizing effect. Hence, because it's weak, it can be stopped by a thin sheet of paper, like we've said here. It can be absorbed as alpha particle are coming. If this is a paper, the paper will stop this from passing this side. They won't pass this side. They'll just be absorbed within the paper. That's for alpha particle. While for beta particle, there's a 5 millimeters sheet of aluminium can stop gamma particles. Sorry, not gamma, but beta particles. They won't pass this side. Now, what of when you get beta particles and you try to pass them through a sheet of paper? They are going to pass because this can't absorb. But when you use aluminium, they will be absorbed and they won't pass the other side. Now we look at the gamma particle. The gamma particle, which is also known as the electromagnetic wave, we are saying it can be stopped by 5 centimeter reed. So this is going to be stopped by a very far 5 centimeter lead because it has got a very high penetrating power. Now, when it comes to diffraction, diffraction in the electric, let's if this is the electric field, let me do this. Discover that a beta particle will be diffracted the smallest, like that, while the gamma, which is here, since it's neutral, does not get affected. It's just a straight, sorry, it's just a straight like that, while the alpha particle will be diffracted towards, because this must be positive side, this must be negative. So since the alpha particle, you know that it's positively charged, you know that unlike charges attract, so it will be attracted towards the positive, but at a higher diffraction as compared to a beta. So this is beta, this is alpha, this is gamma. So a gamma is not affected, it's neutral, got no charge. An alpha particle is positively charged, so it will be attracted to the negative side, but at a higher diffraction. For a beta, is negatively charged, so it will be diffracted to the positive side, but at a very small range. What are we in talk of the magnetic field? Now, in the magnetic field, you know that we have the North Pole and the South Pole. Now, the North Pole acts as the positive pole, while the South Pole acts as the negative pole. So what happens? The alpha particle will be diffracted toward the South Pole where it's negative. So that's what happens. So a beta particle has got always the smallest diffraction as compared to alpha and beta, but gamma is not affected. So thank you so much for watching. This was just an introduction. I'm pretty this is the tutor. I'll catch you in other videos. Don't forget to subscribe, and if you are my students, please I beg you that you can study more, because I'll be posting a video very soon on how on alpha decay, on a decay, and those equations, and application of radioactivity and its effects, or let's say disadvantages, and all those background radiations. So stay tuned.